to section 6.6. We are going to be solving radical equations, so equations that have some sort of root in them, and we're going to use all of the information that we've learned in the chapter to help us do so. So I'm going to start with number 1. We're going to start, I apologize, we're going to start the most simplest one I've got. We've got the square root of x plus 6 equals 3. Now the square root is the part we don't like, so to get rid of a square root, we're going to square both sides. And I can square the 3 also. Well, here's what happens. When we square a square root, they're inverses, so we can get rid of them. So I'm left, on the left-hand side, I have x plus 6. On the right-hand side, we take 3 squared, which we know is the same thing as 3 times 3, which is 9. We can solve this equation by subtracting 6 on both sides. Therefore, our math says that we get x equals 3. Now, when you're going through square roots, you really want to make sure that you check your answer. So we're going to put this 3 back into my original equation. So we're going to take the square root of 3 plus 6. And our question is, do you get 3 out of it? And we want kind of a yes or no. Well, as I look at this, 3 plus 6 is 9. Is the square root of 9 going to be 3? The answer is yes. So x equals 3 is a solution. And I don't box or circle my answer until I've actually checked my work to ensure that I've got the right answer. Okay? Let's take a look at number 2. We have the quantity 3x plus 4 raised to the 2/3 power. That equals 16. Well, we can't get the x inside the parentheses until we get rid of the 2/3 power that's on the outside. So to get rid of a 2/3 power, we're going to raise this to its reciprocal. So to the 3/2 power. And we're going to raise 16 to the 3/2 power as well. Now the one thing that I would suggest to you, when you put 16 to the 3/2 in your calculator, is that you put 3/2 in parentheses. Or you could say 1.5 instead. As I look at this though, on the left side, 2/3 power raised to a 3/2 power will cancel out because they're reciprocals. So on the left side, I have 3x plus 4. On the right side, we take 16 to the 3/2 power, which is just like saying 2's in the denominator, so it's the root. The square root of 16 is 4, and 4 cubed is 64. Now again, your calculator can do that for you if you need. Now I'm back to the Algebra 1, I can start solving. So I subtract 4 on both sides. 3x equals 60. So when I divide both sides by 3, x equals 20. Now I'm not going to circle it yet until I've checked my work. So in my calculator, I'm going to put in there 3 times 20 plus 4. And then I'm going to raise that to the 2 divided by 3 power. And that's basically just how it would go inside your calculator. The question is, if I raise it to the 2/3 power, do I get 16? The answer is yes, so I'm going to circle that x equals 20 as my answer. Now the reason again I wait is because some of the time we're going to check this and we're not going to get an answer that works, and those are called extraneous answers. So I wanted to at least make sure that we've talked about that. You don't have to necessarily show that you checked, but if you circled your answer and your answer is not correct, I will take some points off. Okay, so there's 1 and 2. Let's go down and do 3 and 4. Now I'm going to start with number 4 because 3 is actually the hardest one in my opinion on the notes. So let's start with number 4 and kind of work our way through. If I'm going to solve this root, I'm trying to find x. X is inside a cube root, so I have to get rid of the outside of the cube root first. So I'm going to add 7 to both sides first. 3 times the cube root of 16x equals 17 plus 7 is 24. Now I still have a number outside of my cube root, that's the 3. So I'm going to divide both sides by 3. Now here's the number 1 mistake we make. When we divide by 3, we're only dealing with the number in front. You can never divide inside the root. So we take the cube root of 16x equals, and 24 divided by 3 is 8. Now, the next thing we want to get rid of is the cube root. So to get rid of a cube root, we're going to cube both sides. Just like when we got rid of a square root, we squared both sides. The cube root and the cubed cancel out, so I'm left with 16x equals, and 8 cubed is 512. So to solve, I divide by 16, and I get that x is 32. Now again, before I circle my answer, I better check my work. So in my calculator, I'm going to say 3 times the cube root of 16 times 32. Now this would be my suggestion, is that you put that in parentheses to make sure that you're taking just the cube root of that quantity. Minus 7, the question is, do we get 17? And if you plug it in your calculator, you'll find the answer is yes, so we circle x equals 32. So we're really asking you to solve a lot of the equations that we did in previous chapters. We're just upping the difficulty a little bit with the exponents. Okay? Now, I'm going to do 3, and 3 is the one that's the most difficult, and it really is going to rely on the previous knowledge that we have from Part A. Now, as I look at this, I can tell you right now we don't like the square root. So x minus 2 equals the square root of x plus 10. Since I don't like this square root, I'm going to square both sides. Now here's where the hard part comes in. When I look at x minus 2 squared, it's the same thing as saying x minus 2 times x minus 2 equals, and the squared and the square root cancel out to get x plus 10. That x minus 2 squared requires that you FOIL. Okay, first outside, inside, last. So let's FOIL. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 2 is negative 4. Whenever you have an x squared and x's, you want all of the terms to be on one side, so we're dealing with a quadratic. So I'm going to subtract an x, you only need to do it to one of them, and subtract 10. I'm going to kind of do this all at the same time. If you look at this part here, negative 2 plus negative 2 is negative 4, plus one more negative is negative 5. So I have x squared minus 5x, and negative 4 and negative 10 added together. I'm sorry, this should be a positive 4. I'm looking at my notes thinking this is wrong, is negative 6. I'll explain that again. Negative 2 times negative 2 is a positive 4. There's my math mistake. When you subtract 10, you get a negative 6. And so you end up with a quadratic. And this brings us back to chapter 4 from Algebra 2A, where we asked you to factor this. So let's walk back through factoring again. X squared is x times x. In order to get negative 6, you could take negative 3 and 2, or negative 6 and 1. And if you look at this, the goal of those multiplications is to figure out which grouping will add to be negative 5. Now, there are more factors, but as you're looking at it, I think you can see that negative 6 and 1, because negative 6 plus 1 equals negative 5. So my two factors then are x minus 6 and x plus 1. Because it's equal to 0, we use the zero product theorem, which says I set each group equal to 0, and I solve. So therefore, in the first grouping, x equals 6. In the second group, I say x plus 1 equals 0, and I solve, and I get that x is negative 1. Now, we again are asking you to check. Okay, so I'm going to start way back at the beginning again, and I'm going to try plugging in this 6. So I'm going to say 6 minus 2 does that equal the square root of 6 plus 10? Well, 6 minus 2 is 4. Is that the same thing as the square root of 16? We all know that's a yes, so I can circle x equals 6 as a solution. If I do the same thing for the negative 1, I say, is negative 1 minus 2 equal to the square root of negative 1 plus 10? Well, is negative 3 the same thing as when I square root 9? Well, we know the square root of 9 is 3, so does negative 3 equal 3? The answer is no, so negative 1 is not a solution. This is called an extraneous solution. So mathematically, we believe it should be there. However, when we plug it back in, the restrictions of a square root, the fact that I can't square root negatives, or the fact that I don't get a negative out, are what cause this to be extraneous. Now, normally you don't have to label the extraneous solutions for me. In a quiz or a test, all you'd have to do is write that x equals 6 as a solution. Okay? Let's flip the page. I've got two more for you. Let's take a look at 5. I've got the cube root of 12x minus 5, subtracting the cube root of 8x minus 15 equals 0. Now here's what we're going to do. We want these cube roots to be equal to each other so that I can get rid of some things. So what I'm going to do is I'm going to add this whole cube root to the other side. So I'm going to add the cube root of 8x minus 15. So what I get then is the cube root, let me try that again, that does not look like a cube. The cube root of 12x minus 5 equals the cube root of 8x minus 15. Now, we don't like cube roots, so in order to get rid of cube roots, we've got to cube both sides. So if I cube this side, the cube and the cube root go away. I'm left with 12x minus 5. If I cube this side, the cube and the cube root go away. I'm left with 8x minus 15. And this now is an equation that we can solve. You cannot cube things, though, until a cube root is by itself. So please keep that in mind. And maybe you want to make a note. You cannot cube things until the cube root is by itself. Okay? Now I'm going to start solving this. I'm going to move my 8x over. At the same time, I'm going to add 5. So I get 4x equals negative 15 plus 5 is negative 10. When I divide both sides by 4, x is negative 5 halves. Or some of you might have said negative 2.5. And I would take that because that's a decent enough decimal. Okay? Now when you check this, we just want to plug it back in the original. If I take the cube root of 12 times negative 2.5 minus 5, and this might need its own parentheses, and I subtract the cube root, and let's put another parentheses, of 8 times negative 2.5 minus 15, close my parentheses, do I get 0? Well, what ends up happening is you have the cube root of 35, of negative 35, minus the cube root of negative 35. Well, if I take one thing and I subtract itself, will I get 0? The answer is yes. So negative 2.5 or negative 5 halves is your answer. All right, one last question, and it's kind of like one we've previously done. I can't get inside the parentheses to get x until I get rid of what's on the outside. So I'm going to start with the 1/4 because the exponent is going to come last here. If I start with 1/4, instead of dividing by 1/4, I'm going to multiply by its reciprocal of 4. So I have 7x plus 8 to the 3/2 power equals 54 times 4 is 216. Now, like we did in another question, to get rid of a 3/2 power, we're going to raise this to the 2/3. And we're going to raise this to the 2/3 power also. The exponents here cancel out. So on the left side, I have 7x plus 8. On the right side, in my calculator, again, don't forget parentheses around that exponent, but 216 to the 2/3 power is 36. I start solving. So I subtract 8, 7x equals 28. When I divide both sides by 7, x equals 4. Now we again just want to double check that that works. So in my calculator, I'm going to say 1/4 times 7 times 4 plus 8 to the 3/2 power. And you'll see that I'm kind of putting those parentheses in. Let me make that look like a 3. So that you can kind of see in your calculator where you'll need your parentheses. The question is, does that equal 54? The answer is yes, so x equals 4 is a solution. Okay, we're going to do a warm-up in class on this so we can look at a couple other questions, but this is the general idea. Once you start solving them, you're going to do the same thing over and over and over again. We just got to look for what order to do things. So that's the end of section 6.6. That's the last video for chapter 6. Enjoy the next night off of videos, but thank you for watching.